1-1 solving linear equations and 1-2 solving equations with a variable on both sides. Here's a little bell ringer. Number 1, 5r minus r minus 9 equals 15. Like terms, you can always add a 1 in front of that variable. 5r minus 1r, 4r minus 9 equals 15. Always work on the side with the variable, isolating that variable, getting rid of minus 9 first, add 9 to both sides, 15 plus 9, 24, multiplication, divide both sides by 4, r equals 6. Number 2, distributive property first, multiply everything that's on the outside by everything that's on the inside. 2 times x, 2x, 2 times a negative 3, negative 6, plus 10. Combine your like terms on the same side. We have two constants, negative 6 and a positive 10. Different signs subtract. Sign goes with the bigger number, so that becomes 2x plus 4 equals to 15. Subtract 4 to both sides. 2x equals 11. Divide by 2, and you can either leave your answer as a simplified fraction or turn it into a decimal 5.5. Number 3, to isolate this variable, subtract 4 to both sides, and you have 2/3 x equals 6. Whenever a fraction is being multiplied to a variable, to cancel it out, multiply it by its reciprocal. That reciprocal gets multiplied to the other side. Since I'm multiplying by a fraction, I can make 6 a fraction by putting a 1 underneath it. I can then simplify. 2 goes into itself once and into 6 3 times. So 3 times 3 is 9. X equals 9. Here, solving linear equations, what is the value of x in the equation? First, I need to isolate this variable. I can't do anything with this variable because it's being multiplied by the 2 and dividing by 3. So before I can do anything with this, get rid of the minus 8. Add 8 to both sides. And you have 2 times x plus 4 divide by 3 equals 40. You can then multiply by 3 to get rid of the division, the fraction bar, times 3. 2 times x plus 4 equals 120. Then you can do your distributive property. 2 times x, 2x, 2 times 4, positive 8 equals 120. Subtract 8 to both sides. 2x equals 112. Divide by 2, and x equals 56. And you can always go back, plug in 56 into your original equation, and see if it gives you 32. You can pause it here and try it on your own, see if you get the same answer. Same thing, trying to isolate the x here, get rid of minus 4. 3x minus 1 divided by 2 equals 5. Multiply 2 to both sides to get rid of that fraction bar. This problem does not have a distributive property, so go straight into adding 1 to both sides. 3x equals 11. divide by 3. It's a repeating decimal, so I would prefer a improper fraction as long as it's simplified, which would be 11/3. Here you have variables on the same side, so distributive property first. If it helps you somewhere on the side to multiply, if you don't have a scientific calculator, 1/4 times 3 over 1, and you can put the m up here. Nothing to simplify, so 1 times 3, 3, 4 times 1, 4, so that becomes 3m over 4. You can also put the m on the side. Positive times negative, negative, again you can put a variable, a 1 in front of that variable, and again 1 over 4 times a 1/2, nothing to simplify here, so 1 over 8 m equals 7 over 8. Like terms, variables on the same side, we can combine them together, but when you're adding or subtracting fractions, you need a common denominator. 4 and 8 can both enter an 8. This one I don't have to change since my denominator is already an 8. 4 goes into 8 twice, so 2 times 3 is a 6. Now since I have the denominator is the same, the denominator stays the same. 6 minus 1 is 5. And then to cancel out a fraction that's being multiplied to a variable, multiply it by its reciprocal. My 8's cancel, my 5's cancel. That reciprocal gets multiplied to the other side. I can simplify my 8's go into each other once. Nothing else I can simplify. So 7 times 1, 7. 1 times 5, 5. So my answer is 7 over 5. You can pause it and try this one on your own. First, you should have done your distributive property. 1 over 5 times k, 1 over 5k. Positive times a negative, negative. And again, if you don't have a scientific, you can just put that on the side. Put a 1 over 3 to make it a fraction. Nothing to simplify here. 1 times 3, 3. 5 times 1, 5. There are no like terms on the same side. So to isolate the k, get rid of negative 3 over 5 by adding 3 over 5 to both sides. 1 over 5k equals, add these two fractions, I need a common denominator. Common denominator both between 4 and 5 can both go into 20. So my denominator is now 20. 5 goes into 20 4 times. So 4 times 3, 12. 4 goes into 20 5 times. So 5 times 3, 15. And I'm adding the two fractions, so that makes it a 27 over 20. To cancel out the 1/5, multiply it by its reciprocal, 5 over 1. Bring that reciprocal over to the other side. I can simplify 5 and 20. 5 goes into itself once and into 20 4 times. So 27 times 1, 27. 4 times 1, 4. And you can leave your answer as a simplified improper fraction. Or if it terminates, you can turn it into a terminating decimal. All right, the sum of three consecutive integers is 132. What are the three integers? Consecutive means right after each other. So for example, 1, 2, 3, 7, 8, 9, 11, 12, 13. Write an equation to model the problem and then solve it. So I'm adding three consecutive integers. My first integer plus my second integer plus my third integer has to equal 132. Well, I don't know anything about my first integer, so my first integer is going to be my variable. I'm going to give you an example here of just random 3 consecutive numbers. The second number has to be 1 away from the first, so my second integer is 1 more than my first integer. That third integer will always be 2 away from the first. So whatever my first number is, if I add 2 more numbers, that will always give you the third number. And then the sum of those 3 integers equals 132. Combine all of your like terms. 1x plus 1x plus 1x is 3x. And then 1 plus 2 is 3. Two-step equation. Subtract 3 to both sides. 3x equals 129. Divide by 3. And x equals 12 divided by 3, 4. 9 divided by 3, 3. So x represents my first integer. So then consecutively, the second integer is 1 more than 43, so 44. My third integer is 2 away from the first, so 45. And if I want to check just to make sure I did it correctly, add 43 plus 44 plus 45, and it should give you 132. Pause and you can try this one. Same thing, the sum of 3 consecutive integers is 57. So the first integer plus the second plus the third equals 257. The first integer I know nothing about. That's my variable. My second integer is 1 more away than the first. My third integer is 2 away from the first. Combine all of your like terms. 1, 2, 3x. 1 plus 2, 3. Solve your two-step equation. Subtract 3. 3x equals 54. Divide by 3. And x equals 18. So 18 is my first number, 19 and 20. Example 4, word problems. 4 friends use an online coupon to get discounts on concert tickets. They spent $108 for 4 tickets. What was the price of 1 ticket without the discount? So, step 1, write an equation to represent the problem situation. Let P represent the original ticket price. You have 4 friends multiplied by the original ticket price, which you don't know, that's your variable. Each ticket price was discounted $15. So it has to be written inside parentheses, P minus 15. If you write it without the parentheses, this says that 4 people are buying a ticket and then only the discount gets taken out once. So parentheses is extremely important in this word problem. So do your distributive property. 4 times P, 4P. 4 times a negative 15 is a negative 60. Equals to 108. Add 60 to both sides. 4P equals 168. Divide by 4, and the original price of the ticket was $42. Here, the same 4 friends want to buy tickets for 2 shows on consecutive nights. So 4 friends for 2 shows, that's 8 tickets. The price of the original ticket is what you're trying to find, but now the coupon was for $5 each, and they paid a total of $416. So this is what your equation should have looked like. Do your distributive property. 8 times P, 8P, 8 times negative 5, negative 40, equals 416. Add 40 to both sides. 8p equals 456. Divide by 8. And 8 goes into 45. $57 was the original price of your ticket. Just a recap of solving linear equations. Use the following information about Kelsey's visit to the flower shop. She bought some roses and tulips. She bought twice as many tulips as roses. So they're giving you information about tulips and not roses. So roses is going to end up being your variable. They used X for roses, and then tulips were twice as many as roses. So tulips represents 2x. Roses were $5 each. Tulips were $2 each. Kelsey bought $36 in total. How many of each kind of flower did Kelsey buy? So the cost of roses plus the cost of tulips equals the total cost. We know nothing about how many roses she bought, but we know that they're $5 each. So the cost of one rose, $5, times the number of roses, our variable, so 5x. Cost of tulips, cost of one tulip is $2. They are twice as much as the roses, so 2x equals 36. 5x and 4x. So 2 times 2x is 4x. Combine your like terms. 9x, 36 divided by 9 is 4 roses. And then double that for the tulips. So 4 times 2 is 8. So she bought a total of 4 roses and 8 tulips. You can practice these problems on your own from your textbook. This was our ticket out. Simple two-step equations, solving for k. Negative 6k minus 3 equals 39. Always leaving your variable for last. There's no distributive property. There are no like terms. Adding 3 to both sides. A negative 6k equals 42. Very common mistake. People want to add 6 to both sides, but negative 6 is being multiplied to the variable. So divide. That negative sign also needs to go with it. So finally, k is completely by itself, equals a negative 7. The exact two steps for your fraction, leaving the variable for last. Add 2 over 5, add 2 over 5. If it makes it easier for you to add fractions with a common denominator, you could put a 1 underneath that 5. Common denominator between 1 and 5 is a 5, so 2/5 stays the same. 1 goes into 5 times, so 5 times 5, 25, which makes it 27 over 5, multiplied by the reciprocal to isolate the y, times 3 over 2 to both sides. Nothing here can be simplified. 27 over 5 cannot, 3 over 2 cannot, 27 over 2 and 2 cannot, 5 and 3 cannot. So just multiply straight across. 27 times 3, 81, 5 times 2, 10, and that would be your answer, or 8.1 if you want to leave it as a decimal. And that was 1-1. 1-2 now has variables on both sides of your equation. Here's an example. Use the following information about Aki's and Hakim's walkathon. Aki walks at a rate of 3 miles per hour. Hakim walks at a rate of 4 miles per hour. Hakim begins half hour after Aki. When will Hakim catch up to Aki? So when will their distances equal to each other? So they put Hakeem here on the left. He walks at a rate of 4 miles per hour, but he left 0.5 hours after Aki. So whatever Aki's hour was minus 0.5 was his time multiplied by his rate. Aki is walking 3 miles per hour. So they did the distributive property. 4 times h, 4h. Half of 4 is 2. Positive times a negative, negative. Variables on opposite sides, one has to cancel. They canceled the negative 4h, the negative 4h. They brought down the negative 2 equals 3 minus 4 is a negative 1h. Always work on the side with the variable. Divide both sides by a negative 1, and it took 2 hours for Hakeem to catch up with Aki. All right, before we can start canceling anything out on either side, we need to make sure all our distributed property is gone and any like terms simplified as well. So here on this side, I have a 3k and a positive 4k. I can combine them together. They're on the same side. On the right side, I do have a distributed property I need to multiply. Watch your signs. Negative 2 times x, negative 2x, negative times negative, positive 8, and then plus 9. Now I have like terms on the right side. So I'm just going to bring down 7x minus 10 equals negative 2x. Combine these two together, positive 17. No more like terms. I do have a variable on the left, a variable on the right. One has to cancel. Easiest way is to cancel the smallest. So that way you deal with positive numbers. Getting rid of a negative 2, positive 2x to both sides, 7x and 2x, 9x minus 10 equals this completely canceled out, positive 17. Add 10 to both sides. 9x equals 27. Divide by 9. And x equals 3. Another example here, getting rid of your distributed property. Half of n, 1/2 n. Half of a negative 4 is a negative 2 minus 7. Please, please, please never cancel on the same side. Same combining, same sign, add, and keep the sign. So that's going to make it a negative 9 equals negative 2n plus 6. Variables on opposite side. One has to cancel. I always like to do the smallest. Positive 2n. 2.5 makes it 2 1/2. But in dealing with equations, you want a improper fraction. So 2 times 2, 4 plus 1 makes it 5/2n minus 9 equals a positive 6. Solving for the variable, add 9 to both sides. 5/2n equals 15. Multiply by the reciprocal, 2/5. That reciprocal to the other side. Make 15 a fraction by putting a 1 underneath it. Try simplifying. 5 goes into itself once, into 15 3 times, and then 3 times 2 is 6. So n equals 6. Now you can pause and try the triads on your own. Check your answer after. 100 times z, 100z, 100 times negative 0.2. Remember when you're multiplying by 100, moving over the decimal place twice. So that would be minus 20 equals negative 10 times 5z, negative 50z. Negative times a positive negative, I'm multiplying by 10, I just move over that decimal one space. Minus 8. Variables on opposite sides. Negative is always smaller. So I would have added 50z to both sides. 150z minus 20 equals, very important, bring down that negative 8. Add 20 to both sides. 150z equals 12. Always divide by the number with the variable. And then you can either try getting a decimal, or you can always start small. 2 goes into 12 6 times. 2 goes into 150, 75. I can't divide by 2 alone. 2 again. I can divide by 3 next. 3 goes into 6 twice. And 3 goes into 75 25 times. So that would be your simplified fraction. Letter B, distributive property. Again, somewhere on the side, you can multiply those two fractions. 5 over 8 times, you can put 16d over a 1. Try simplifying. 8 goes into itself once, into 16 twice. 5 times 2 makes that a 10d. Do the same thing with the 24. 5 over 8 times a positive 24 over 1. 8 goes into itself once, into 24 3 times. 5 times 3, positive 15, equals distributive property over here. 6 times d, 6d, 6 times a negative 1, negative 6 plus 1. Bring this down because I have like terms on the right side. Different signs, subtract. Sign goes with the bigger number, so that becomes a negative 5. Variables on opposite sides, I would get rid of the smaller variable, minus 6d, 10d minus 6d, 4d plus 15. Don't forget to bring down that negative sign. Subtract 15, but just because you're subtracting does not mean you're going to subtract 15 and 5. They have the same sign, so you're going to add them together and keep that sign. Divide by 4 as your very last step, and d equals a negative 5. So up to now, everything that we've done from 1-1 to the beginning of 1-2, we've gotten one answer, so that would make it one solution. Now we have some special solutions. When I go to distribute, example 2, understanding equations with infinitely many or no solutions. 2 times 2x makes that a 4x. 2 times 3 makes that a positive 6. You can tell already that both sides are identical. So what's going to happen when I now cancel out a variable, it's not going to matter which one, because since they're both positive, when you subtract 4x to both sides, they're both going to cancel out on both sides. Bring down the remaining numbers that you have left over. A positive 6 equals a positive 6. This is a true statement. So this would be called identity. An identity is true for all possible values of the variable. So once the statement is true, that means that you have infinitely many solutions, or as I just like to make it easier and call it IMS. This would be a final answer, not the problem solved. And then you have times when it's not going to not be the same. We have 6x minus 5. When I go to distribute here, 2 times 3x, 6x, 2 times a positive 4, positive 8. When I cancel out my variables that are both positive, they're both going to completely cancel out again. I have a negative 5 equals to a positive 8, which is not a true statement. So this would end up being a no solution. There is no variable that would be able to be solved, or no variable that would make it an identity. So this equation has no solution. You can pause here and see which one is no solution and which one is IMS on your own. Letter A. I always tell my students whenever there's a negative right in front of a parentheses, put a 1 right between the sign and the parentheses. You are distributing by a -1, which makes that a -27, and a negative times a negative is a positive t. You can tell it's identical to a positive t on both sides, a -27 on both sides. When I cancel out that variable, they end up canceling out on both sides. A -27 is the same as -27 on both sides. So this would be infinitely many solutions. Letter B, distributed property, 16 times 4, 64. 16 times a -3m is a -48m. You can put a 1 here if that helps you. Positive times negative, -96 times a half. Half of 96 is a 48m. 96 times a +1, positive 96. I always like to do my variables first. Positive 48m to both sides. Cancels out on both sides. 64 does not equal a 96. That statement is false, so that would be no solution. Do you know how? We can just go over these 4 equations. 10x equals 8x plus 18. In this case, the 8x is the one that has to go over to the left side. That way you have something on the left and something on the right of the equal sign. So I would minus 8x to both sides. 10x minus 8x is a 2x. That canceled out here. Equals to 18. Divide by 2. And x equals 9. Number 6, again, the -9h is the one that has to be brought over to the right side. Add 9h to both sides. And a -28 equals a positive 14h. Divide by 14, and h equals a -2. Number 7, if you want to put a 1 in front of this y, that could help you. Distributed property, 2 times y, 2y, 2 times -6, -12, this is number 7 over here, equals 3 times y, 3y, 3 times -4, -12, minus 1y. Before I start canceling anything out, combining my like terms, 3y minus 1y, 2y minus 12. I can already tell here it's going to be an IMS because both sides are identical to each other, but I can just go ahead and cancel out the variables just to make sure. A -12 equals a -12. This answer would be IMS. Number 8, distributed property. 8x minus 4 equals 8x minus 8. Subtract 8x to both sides. My 8x's cancel out. A -4 does not equal a -8. So this would make it no solution. Number 5 is a word problem. For how many games is the total cost of bowling for one person equal for the 2 bowling establishments? So when is family bowling going to equal night owl bowling for the same amount of games? So games is what I need to find. So games is my variable. So starting off with family bowling, An expression for family bowling can be $4 per game plus a one-time shoe rental. That number should not have a variable. Night owl bowling is $3.75 per game plus a one-time shoe rental per person. No distributed property, no like terms. I do have variables on opposite sides. So minus 3.75G to both sides. $4 minus 3.75 should be a quarter. Oop, forgot my G here. That canceled out. Plus 1 equals to 2. Minus 1 to both sides. 2 minus 1 is 1. Divide by a quarter. And whenever you're dividing by a decimal, you can just remove that decimal, move it over 2 decimals, and then add 2 zeros here at the end. And 100 divided by 25 is 4. So it would take 4 games for both establishments to cost the same amount of money. You can work on these on your own for practice. And this was a ticket out. Write and solve an equation and solve the problem. We have Tanya's dog walking service. She charges a flat rate of $20 per month plus $3 per mile that each dog is walked. Beth does not charge a monthly fee for her dog walking service, but she charges $5 per mile that each dog is walked. Write the equation that can be used to find the number of miles M for which Tanya and Beth would charge the same amount to walk one dog. So when is Tanya gonna equal to Beth? Tanya charges a one-time flat rate. You only pay it once and that's it. In addition to that, plus she charges $3 per mile. So 3 times M equals Beth only charges $5 per mile, no monthly fee. So that should only be a 5M for Beth. Variables on opposite sides. The 3 is the one that's going to have to go, minus 3M to both sides. Becomes a 2M, divide by 2, and at 10 miles, both companies, both Tanya and Beth, charge the same amount of money. If they would ever ask you how much money would that be, you can either plug it in for either Tanya or Beth. Beth would be the easiest at 5 times 10, which would be $50. They would both come out to be the same amount. And that was lesson 1.1 and 1.2.